4 material, which deals with multiplying polynomials. I'm going to start off with a basic concrete example, so kind of building off of what we already know and then kind of translating it into a little bit more of a complex way of thinking it, but also showing you that they are actually one and the same. So recall that we've done something along the lines of, say, 6 times the quantity 2x plus 3. When we had done this before, what would you do in order to simplify this expression? And hopefully you're thinking, well, in my years of experience with problems like these, I would distribute the 6 to each of those terms. So this would eventually give me 12x plus 18. So I'm going to change this up a little bit, okay? Really to illustrate a point and to kind of help bridge what we are going to look at in this section. So what I'm going to go ahead and do is I'm going to just rewrite the problem a little bit differently. Do you agree that 6 can be broken into an expression such as 3 plus 3? Okay, so in other words, I'm just expanding the number out. So instead of having it as one solid constant, I'm going to break it up into the addition of two numbers. And for the record, with this particular example, I could have done any sort of addition or subtraction problem where two numbers would equate out to becoming 6. So here's what I want to show you. Okay, this is a method that we will call foiling. So, and I will explain it, and I will explain the idea of foiling in the next example. So, but what I want you to know here is I'm first going to focus on this 3 in this quantity, and I'm going to distribute it to each of the terms in the other quantity that I provided for you. So 3 times 2x gives me 6x, and then 3 times 3 will give me 9. So now if I go through here and I do the same thing, a positive 3 times a positive 2x gives me a positive 6x, and a positive 3 times a positive 3 gives me a 9. So notice in this case what you are able to do in this expression, and hopefully you're saying, well, I can combine like terms. Well, notice something interesting is happening here. I have a 6x and a 6x, both of which are positive. If I combo them, I get a 12x. I have a positive 9x and a positive 9x, both of which are constants. If I add those up, I get 18. So I do want you to note here, it's no coincidence that even though I changed the structure of how 6 looks, so in other words, even though I changed it to a 3 plus 3, or maybe if I changed this to a 7 minus 1, or a 4 plus 2, I will still get the same solution. Okay, that's not a coincidence. So the reason why I showed you this is because we are going to start looking at multiplying two binomials together. So the example that I'm going to show you is going to look like the following. I'm going to scoot this out of the way so we have a, no I'm not. Let me get rid of that line. I'm going to go ahead and just write it down here. Our problem that we're going to look at is going to be 5p plus 3 times the quantity of 3p minus 4. So what I want to show you in here is how I'm going to basically mimic what we had done above. So I'm going to focus my attention on the 5p. And remember, we are going to have to distribute. And since we have two terms, we should only focus our attention on one term at a time. So what I'm going to do here is I'm going to do 5p times 3p. So I'm going to go ahead and write that down just as I see it. Okay. Then I'm going to have a 5p times a negative 4. So right off the bat, a positive times a negative will tell me that I will have a negative sign that will come up, and then I will multiply that 5p times the 4. Now again, if you're like, but wait, it was a negative 4, that is right, but I did indicate the negative right over here. Okay, So the positive 5p times the negative 4 will give me this negative sign that I have on my line below. So now I've distributed everything. Do you agree that everything in the second quantity, that 3p minus 4, has been multiplied by the 5p? Much like how we had the first 3 that I have in purple being multiplied with each of the terms, 2x and 3 in the second quantity. So now I'm going to go ahead and focus my attention on this positive 3 here. Okay, so the first thing I'm going to go ahead and do is I will multiply the 3 times the 3p, so it's a positive times a positive, so I know that the sign will be positive. And then I will have 3 times 3p. Then I will also do a positive 3 times a negative 4, which gives me which will give me a negative answer. And then so that a negative answer will be 3 times 4. Now I know that you probably have already said, well, negative 3 times a positive 4 gives me negative 12. I'm just trying to be consistent with what I have going on in my work. So the last thing that I'm going to go ahead and do, or maybe second to last thing, is go ahead and clean this up. So 5p times 3p, so we can really just focus on the numbers here. So 5 times 3 is 15. P times p, in other words, we can use our product rule. Since we know that each of these p's has an exponent of 1, p times p would be p squared. There's our minus sign. It's just going to drop down. 5 times 4 is going to be 20. And the p that I have in the second term does not have anything to multiply with, so it's just going to drop down. Next we have a plus. Again, 3 times 3 is 9. And the p in that term doesn't have anything to multiply with, so it drops down. Then we have a minus. And then 3 times 4 is 12. Now the very last thing that we can go ahead and do here is note that I do have like terms that are noted in the middle here. So I can consolidate that down. So I have 15 p squared, and then a negative 20p plus 9p. So remember that we treat this like counting. So if I have negative 20 p's in this group and positive 9 p's in the other group, then if I combine them, then I have a total of negative 11 p's left over. And then I have my constant, negative 12. This is as far as the answer can go. I've simplified it as best as I can. So I did say that I would talk about foiling, and let me go ahead and mention that really quickly. So I'm going to go back to the second line, and I'm going to indicate that with an arrow. So FOIL actually is a nice little acronym to help you keep everything organized. So foiling means that you're going to multiply the first terms. So notice that the 5p and the 3p are the first terms in their respective binomials. Then I'm going to go ahead and multiply the outer terms. So the 5p is on the outside of the expression, and the negative 4 is on the outside of its expression. So they're on the outskirts. I represents inner. So notice that the 3 and the 3p, they're the two terms that are kind of mashed in the middle. And then L stands for last. So the 3, the positive 3 in the first grouping and the negative 4 in the second grouping are the last terms in their binomials. So, and that's exactly what we have here. So 5p times 3p, these are the first terms in the binomials. 5p times 4 are the outer terms when you just look at the expression or the multiplication that you've seen here. 3p and 3 are the inner terms that you're seeing, and 3 and negative 4 are the last terms in both of the outer expressions. So I hope that this brief tutorial was helpful. I hope that the initial example that we use kind of helped bridge to what we are working towards when we actually have multiple variables sitting in these positions. Please let me know if you do have any questions or if you need follow-up videos or anything along those lines. Thank you very much.